Hi Trev, I'm back in England. You're going to get sick of the sight of this spreadsheet, I'm sure. What I'd said initially, obviously, I've done all of that. I'm a little bit bored with that at the moment, and I just needed a bit of a side issue. So I started developing the U-value calc side of it, and I was going to stick that in this side of the spreadsheet. Now, I started off on the cavity wall, and I'll come on to that. But basically, what I wanted you to have a look at was the overall kind of data input. And this is typical rafter with insulation under. Rafter with insulation between and under, and I've also incorporated multifoil insulation as well. What I've done two diagrams there. This diagram, the under insulation, but they're roughly the same thing. And the idea is that the spreadsheet starts at the top, which is the external surface resistance, hence the external surface resistance, and it runs all the way down to the internal surface resistance. And depending upon which of these two systems has been used would depend upon which of this slot's actually filled in. What I'll do, I'll just what they call it, all of this for the time being. And so I don't know why that's in that. So obviously I've been checking all of the I've been working this afternoon on the multifoils, which has been quite interesting. Anyway, so that's the spreadsheet. So the white is roughly the top, effectively from that rafter cavity up over. The between insulation to the under insulation's that piece there. And of course the between insulation is bridged by the rafters, and that's all taken into account by all of this malarkey. And then the under insulation, then after that it is the blue's multifoil, so we don't touch that unless we are on the multifoil, and then we on the internal board, the finish and the surface resistance for the end. So if we do an under insulation scheme, so the surface resistance seems to be pretty much cast in tablets. Although having said that, I've seen various different calculations where this changes. Roof covering, I've got little drop down menus there, and if it's a concrete slate, I've given that 10 millimeters. Then we move down to the batten cavity, which I would consider that as ventilated cavity, which we get a little bit there. And then the rafter cavity, which is underneath the breather membrane, I'm gonna go for a unventilated cavity there. Between insulation, now before I go into the between insulation, there's various different. What I've done here, obviously I've got lots of different insulations there, and I've pinged them all in. But what I've done on the GA4000, I've just upped that to the K value of 0.026. Now, all of Celotex's stuff is coming out on where is it? If you're using it's coming out 0.022. If I use 0.022, I end up with U values that's much lower. And obviously, where I told you that I'd downloaded this, which is Build Desk, and I played around with Build Desk, and if I insert into Build Desk, which I'm not all that familiar with the program yet, but I very rarely get anywhere near 0.22. So I've upped it to I've upped for the purpose of this, I've upped this to 0.2026, and everything starts fitting into place a little bit better. But that's the reasoning behind that. So we'll stick 100 millimeters in. And what I forgot is right at the beginning. Forgot the start. Jumped in and forgot the start. Obviously, the start is the rafter depth, the rafter width, and the centers. Obviously, the rafter depth depends. You know, we get some thermal insulation through the rafter, and the rafter width will depend upon how much insulation and how much rafter there is, and the centers obviously determines that. And that calculation there, the zeros 865 and the 0135 is the proportions of insulation and rafter. And if I push that up to 600, you'll see that change. If I drop that to 300, you'll see a change in the favour of the rafter. But we'll do it at 400 centres. So that changes the what I've called it is the thermal bridge, the bridge modification. So if I put 100 millimeters in there, it gives me an R value of 3.8 if that's a continuous layer. But because of the rafter, and that should be equals to that. I'm going to say now we're cooking. Don't know how I'd lost that. But if I put the 150 rafter in there, then it modifies it. There's a modification there. So the modified R value is not as high as the unbroken, but obviously much higher than the rafter, and that's a calc there for the to proportion the weighting of the values. Okay, so we'll put 40 millimeters on the under insulation as we're working down through the system. We're not using the multifoils. We get the internal board, plasterboard. Got a few others in there, but basically 99 times out of 10 is going to be plasterboard, and that'll be 12 millimeters. And the K value has already been brought in from the drop-down menu, and neat skim, and that gives us as close as damn it 0.18. If I change that to 50, now what's interesting is in the Celotex website. If I run that through the Celotex website, 100 between and 50 underneath gives 1.8, and if I put 40 underneath, it gives us 1.9. But the what they call it website, the LABC website, allows 35, which gives 1.189. Now, if I change to 0.022, if I use the R, because that's use the R, where's the R? Use the R. See how huge difference. I'm down to what was way below, which was way below on the Celotex, way above on the Celotex website, I should say, is now, you know, way below. That was what Celotex was recommending when I ran through it. That's given it. If I use 0.022 lambda value, oh God, I hate that term, K value I should say, it comes in really low. But to get in tune with the with most of the websites, I've detuned that. Obviously, like I said, the engine room. The engine room is something I can fiddle with. You know, it'll probably take me another 2 or 3 months to get this lot to a position where we can say, yeah, let's go and hand it out. So that's that. The other system is the multifoil, and that's quite interesting as well, because I'll get onto that. But let's run through it. Let's run through a Super Quilt TLX. What did that give? Not to worry, but we're not to worry about that. Surface resistance, roof covering, that's still all the same. Between insulations generally around about 80 millimeters. Rafter stays the same, etc. Under insulation doesn't exist on this because we're going to use the multifoil. I'll do the multifoil first. I'll use the TLX silver. Now, when I did a little bit of research on it, they were claiming all sorts of total R values of anything up to just short of 3. But when it came down to it, the core value, the 3 was including these cavities either side. So what they're claiming is, if I can roll into this, what they're claiming is that there is obviously, I've already taken into account the batten cavity, I've already taken into account the rafter cavity. Now what they're now saying is that there's a upper multifoil cavity, and that's going to be low emissivity, or however you say it, because that's got aluminium foil on the PIR, and that's got aluminium foil on the PIR. So we can use a low emissivity, however it's pronounced, in there. And they're claiming the same underneath as well, because obviously how I've shown that's not technically how it is. That batten sinks into the into the multifoil, and how much of a void there is there, I would doubt. But they're claiming it, and they're claiming it bigger than I've seen in any of the documentation. But this isn't working out too bad actually, by just using the cavity values that you're allowed. So I've used the TLX silver at 1.52 and put a low emissivity, a low E. I never thought about using low E. A low E cavity there above it, and a low E cavity below it, and it's coming out. Obviously the plasterboard needs skim and RSI is all still the same. It's coming out the same at 1.82, and they're claiming 1.8, and I'll take 2 1,000ths of a U value as a but that's using these values here. If, like I said before, if I drop that back down to 0.22, see quite a big difference. You know, we down to 0.168, and that's using my low E cavities. Now that comes in about 0.34, and that seems to be in accordance with the British standard 6946. But they, in their calculations, are claiming anything up to 0.5 either side of it, which has given them an overall R value of about 2.5. But what I've just been taking the core R values that's been tested by, it's had third-party testing, and these cavities will depend upon what's in reality rather than them claiming it. But it pops it into the right field. And so I did that one. I did them two, that one there. So, you know, cast your thoughts on the mythology of that. I can't think of anything simpler. Start at the top and work on the way down. And I'm sure, you know, the majority of the surveyors, you know, if they appreciate this kind of thing, because it just seems to be very difficult to find even the U-value calc on this 250 quid piece of software is anything but intuitive. It's good, or it will be good when I learn how to use it better. But, you know, for what we need, I think a series of these spreadsheets is going to do the trick. I did a one on cavity walls, and there's lots of cavities in there as well, so that's as difficult. Let's pull it in a little bit. That's as complex as it can get. So it'll deal with a cladding, a render, with a cavity behind, may have insulation behind that, you know, something like inshalath on render, masonry leaf, partial fill cavity, but obviously it'll deal with it. If it deals with anything that's partially cavity, it'll deal with a full. Insulation, masonry leaf, insulation. I'll put insulation cavity. It would normally be cavity insulation, or alternatively, that insulation might be sat on for garage conversions, for argument's sake. That insulation may be between battens, cavity there, lining and finish. So we've got external surface resistance there, internal there. So if we run through one for quickness, let's give a little bit of central aspect to it. So external surface resistance points forwards, casting tablets, cladding materials. Let's go for a render there. We could render it, and we'll put 30 millimeters of render. So that's the 30. Insulation, there's no insulation in this particular case. There's no cavity in this particular case, so we leave these blank. Masonry leaf outside. We've got whatever you want in there. I think everybody loves a bit of plasma, don't they, these days? Where's a plasma? So we'll use 7.3 Newton on the outside. Yes, there is a cavity, and it's unventilated. The insulation, the plasma is 100 millimeters thick, getting carried away. The Celotex is 50 because it's partial fill. And obviously, if it was a full fill, that would be 100 millimeters, and that cavity wouldn't exist. So we delete. We'd have no cavity in there. So unventilated cavity. Inside leaf. Put an ordinary Celcon. See how it works with an ordinary Celcon. So we've got, and then we put 100 millimeters into that. How are we doing? Are we getting close at 0.2? Now, so if we didn't do any insulation on dabs or insulation between battens, and we went straight to plasterboard, and 12 millimeters in there, and we are struggling. And the finish 2.29. So what we could do, if we went to Celcon Solar, and that's as close to 0.282. 0.282 is 0.28 as far as I'm concerned. So that's basically it. If we went in terms of, I don't know, garage conversion, Could run a garage conversion through there quite easily. Let's get rid of these. And ventilate the cavities. No cavity. If it's 5.882, then I know everything's clear. So what we could do, we could have a masonry leaf. Masonry leaf might be 100mm facing brickwork. As we're doing a garage conversion, could be a cavity. There would be a cavity in there, so that will be an unventilated cavity. And sell it, so it wouldn't be that Celotex. We do its insulation between battens. So if I tried 70mm there between battens, and he doesn't fancy it, although we've still got our plasterboard to go in there, 12mm plasterboard, 3mm thing. Might have to ping that up to 75, and there we go, 75. So it will be flexible enough to do. If I've made it as complex as I can with this on the left, and then everything else will be less complex, and it'll be just a matter of filling in the relevant pieces of information. The reason I've got insulation between battens there, I've dimmed that down but I never thought about this, what the system I've just done, because that's effectively on battens or with battens in between. So you might have tuber ones at 600 centres. It's going to be roughly the same. So it would work, but obviously I would need to explain that a little bit more in a side note. What I'm trying to do here is to try and demonstrate how flexible it is. So if we design for the most complex external wall, then we can dim it down. You know, if we're going down that particular route where we had something like cladding material on the outside, maybe timber, 10mm of timber, and you might have some insulation in behind there. There might be 25mm of Celotex. There's a cavity there, but that's probably because outside's likely to be ventilated. So we've dealt with the cladding, we've dealt with the cavity, we've dealt with the insulation. We could deal with the block work, put something a little bit more substantial, something like that sat on it, rather than then we down to our cavity for the partial fill. Celotex 50mm, internal leaf hit. I hate we'll use an Armstrong lightweight, make that 100mm. And then we might have a insulated plasterboard on dabs, in which case it would be a cavity, an unventilated cavity, and then we may have say 30mm. But that may be, I might use styrofoam or something like that. I know it says floor mate, but it's the same R value. So we've got 30mm of that. We've got nothing in there, no insulation between there, and then the plasterboard on dabs. And something's gone wrong, and that's the reason. There's a couple of things that need ironing out, and that would be, like you say, quite a healthy U value. And that's more or less it. I've done the warm deck roof one as well. but that's like I say again, that's coming out extremely economical. It's coming in. It's coming out like the LABCs. All the the LABC U values tends to come out more economical than than their own websites, and I think it's down to how much they dim down their K values, and certainly Build Desk does. This dims them down. These aren't as high as what I would have expected them to be. But like I said, I've got to get to grips with this program, and speak to Steve, who's the guy. But that's more or less about it, Trev. Tell me what you think. Everything's jammed up. No, it hasn't. Everything. Tell me what you think. But that's how I see it working. And where's the return to menu? What I'll do, I'll ping you a link for the video. Obviously, you'll have the link to the video. Otherwise, you wouldn't hear this. And this revised version, and how to get to it is obviously is down there. Okay, bud. Speak to you soon. Bye bye now.